Graphite as anode material generally occupies about 20 to 30% of the lithium-ion battery cells, meaning roughly about 150 pounds, about 68 kilograms for a 70 kilowatt hour battery pack. It depends on how big is the battery pack, right? Tesla has a different size to Tesla Model 3s, 1 and so forth. So on an approximate basis, anywhere between 800 grams to a kilogram of graphite, anode quality graphite particles will be there in a battery pack. So if you take that number and see the cost share of graphite, so that's generally about 7% of the cost. So it's a 30% in the materials, but 7% of the cost. So graphite is relatively inexpensive part of the battery cell compared to the rest of the battery cell that stores the energy. Now, whereas the lithium inventory in the cell, that comes from cathode. That's not anode job, that's cathode that provides the lithium inventory. Graphite anode is what stores the energy. So once you have charged the battery, graphite is what stores all that energy and then delivers that, for example, when you are driving the car. So anode is sitting there as a pivotal role in storing the energy and then delivering it when you need it, right? That's graphite's primary job. So for a electric vehicle battery cell, graphite is almost like what human heart does for our body, pumping in and out that energy. So the quality of that graphite controls battery storage capacity, battery cycle life, capacitor retention over cycles. For example, how long you can store energy to 80% capacity, right? Whether it's 500 cycles or 3,000 cycles. That depends on the anode. The discharge rate, for example, when you are accelerating an electric vehicle, the power that has to be drawn, it comes from the anode. So the quality and the efficiency of that anode material dictates how well your electric vehicle is performing. So the power of the car, those 0 to 60 metrics, acceleration, all that performance related parameters, that actually originates from the anode. Now, going forward, graphite is expected to occupy about 90% of the anode market share past 2030. Right? What would that mean in terms of graphite? So it's estimated that there will be, here are some numbers, right? It's estimated that there will be 160 million electric vehicles by 2030, right? Now let's assume they're all average 60 kilowatt hour pack, a little higher than Tesla Model S, lower than Tesla 3. So that, and if you take 50% of that natural graphite, then it turns out to be roughly about 9.6 million metric tons of anode quality graphite particles. And this is a worldwide market, right? China alone cannot supply it. There is it's very little processing capacity at the moment. That actually, even though if you have the raw graphite to be able to process it and then make that battery quality graphite, that's a huge deal. And our current manufacturing process that's used in China and rest of the world, that gives you 30% yield. Now, take that 9.6 million metric ton of demand and then put 30% yield, see how much graphite you need, right? So there is the processing opportunity. That is graphite being a critical component of the battery, as well as it's not just graphite, right? To take that raw graphite to make that anode ready graphite that can go into electric vehicle batteries. So both these parts, graphite as a critical material, also us in Urbix as the critical processing part that can enable that feature. So Urbix process increases that yield significantly, close to 70%. So that also makes this a very interesting opportunity for Urbix, so that we can use, so to say, a lesser window of material and convert it to a higher value anode grade material. These are all the critical factors, right? It's not just graphite, the material alone, but also the processability and the capacity to process and make that high value graphite. So both are, in my opinion, both are very critical factors going into that electric vehicle future.